Let us discuss the mechanical properties of metals. These mechanical properties are concerned with the ability of material to resist external loads. So, if you see these mechanical properties, how these are being affected when these materials are subjected to the external loads. The loads may be of in various ways. The first property, if we see strength, strength is nothing but it is the ability of the material to resist external loads without yield or break. So until the material is break or yield which resist the loads, this property is called strength. The second property is hardness. Hardness is the ability of material to resist wear and indentation. Okay, so if we consider a metallic material, okay, and if the material is under wear and tear condition, the material is to be operated under wear and tear conditions. So which has the material which has the property of more hardness, that type of material will be used under such conditions. And the third property is toughness. Toughness is the property to resist fracture due to impact loads. Impact loads are nothing but the loads are being applied, however those are dynamic loads, means the loads which has certain velocity. With the velocity the loads are being applied on the material. So under those conditions also the material should have the resistance for its fracture. So this toughness which resists the fracture during the dynamic loads or impact loads. The fourth property of mechanical property of material is stiffness. Stiffness is nothing but it is the ability of material to resist deformation under stress. So when the materials are subjected to loads, definitely there would be some sort of stresses. So due to that stresses, strain may form. That strain is nothing but deformation. So the material should resist to the deformation under the application of external loads or under the influence of stresses. The ability of material to resist deformation under stress is called stiffness. The fifth property of mechanical properties of metal is creep. Creep is a permanent deformation when the material is subjected to constant loads at high temperatures. There is certain examples like shipbuilding or aerostructure applications. If we observe, there the materials are subjected to constant loads, but the materials are under high temperature, so it has high temperature as well as some loads are being acted on that structure. Okay, so due to these two factors, one is constant load and the second one is the application of high temperature, there would be a permanent deformation. Okay, so the permanent deformation when the material is subjected to constant loads at high temperature is called creep. The sixth property, if you see, it is fatigue. Fatigue is the failure of a material when it is subjected to repeated stresses. So several times if we observe automobile parts, okay, these automobile parts, those are subjected to repeated stress. Okay, so due to this repeated stress, what happens, the material will undergo failure after certain uh, number of cycles, that is called its endurance limit. Okay, so the property of like such failure when it is subjected to repeated stresses is called fatigue. Now let's see the next property. It is elasticity and plasticity. If we see the elasticity is nothing but it is a property of a material to regain its original shape from the deformation when external load removes. Okay, so definitely we know the material will undergo to certain deformation when it is subjected to load, external loads. So if we remove the external loads from the material, okay, then the material will come back to its original shape. That property is called elasticity. Now if you see the plasticity of the material, this plasticity of the material is nothing but what? It is contradictory to the elasticity. In the elasticity, the material will come back to its original shape after the removal of load, external loads acting on it. Whereas in this case, this plasticity retains the deformation of the material under external loads permanently. Okay, this is like permanent deformation occurs even after removal of the external loads. Okay. So when the loads are being applied on the material, it go to the deformation. Okay, so even if you remove those external loads, the deformation will continue in the material. It will not come back to its original shape. Okay, that property is called plasticity. If we see the characteristics of a metal when it is subjected to external loads, so definitely we know there is deformation when it is subjected to loads. Okay, that deformation is due to stress produced in the material. So if we draw a graph between the stress and strain, stress is in y-axis and strain in so it will exhibit the property as like this. Okay, so we can denote some key points on this stress strain curve. Okay, so there are key points. For suppose here one is there, okay, and here and that is there. Okay, this is the proportional limit, this is the yield strength. Okay, I'm writing here proportional limit. This is yield strength. Yield strength. Okay, and this point is the ultimate strength. Okay, and another point which is here, it is fracture. It means at the final the metallic material will go to fracture, while it is exhibiting certain characteristics up to proportional limit. One way it exhibits up to yield strength, up to ultimate strength, up to fracture. Okay, so the strain will cause in the material the application of external loads which exhibits two properties as we emphasized, that is of elasticity and plasticity. Now if you see this graph, up to which point it gives elastic region and up to which point it exhibits the plastic region, let us see. So here this stress is directly proportional to strain up to proportional limit. Okay, so whenever the removal of stress, the strain will also be removed. Okay, so this property is called proportional limit. However, the material will exhibit this elastic property till the yield strength. So if we draw a line up to yield strength, okay, so this is a line drawing up to yield strength. Okay, then the area cover up to yield strength, the region is called elastic region. Okay, so the region is like, if we say this is the region. Okay, so this region will be elastic region up to yield strength. Right, so it is clear what is the elasticity property of a metal in the stress strain curve. The same way, if we see beyond the yield strength, what is happening? Okay, so beyond the yield strength, the material will undergo load. Of course, it exhibits some strain or deformation in the material, but during this region, the material will not back to its original shape. Okay, so it happens till the point of fracture. So we can draw a line up to the fracture point. Okay, so the stress strain curve from the yield strength to the fracture point, which exhibits the plastic region, or which exhibits the property of plasticity. So here you can identify, so this is the line. Okay, it is nothing but plasticity. So for our manufacturing process, sometimes we have to do several manufacturing operations in elastic region. Sometimes we have to be concentrated on plastic region. For suppose if you see the forming process, forming will be done when the material is under plastic region. Okay, likewise the manufacturing operations will be performed. Now the next important mechanical properties are ductility and brittleness. If we consider ductility, this property enables the materials to be drawn into wires with the application of tensile loads. Okay, so thin wires can be produced with this property of ductility. So whenever the loads, especially tensile load, applied on the material, then this property which enables the material that the material can be thinned and it can be drawn into wire. Okay, so if we saw the stress strain curve just before, which is for the ductile material. The next property, brittleness, which is just opposite to the ductility nature of the material. So this brittleness, which exhibits the material to break with little permanent distortion. I mean to say that small amount of distortion will be there and then it will break. Unlike ductile materials which exhibits deformation, if you see this ductility and brittleness properties on stress strain curve, how it appears. So here drawing stress and strain curve. Okay, now so on the ordinate it is stress and on the x-axis it is strain. Okay, so the simple graph, if we see a material, okay, so it will expect for ductile material, this would be the graph for stress strain graph for ductile materials. Okay, the same way here, if we draw the stress strain curve for brittle materials, how it appears. Okay, so this is okay, which exhibits very less deformation. The strain is very less as compared to ductile materials. Okay, so the material will break at this point of time. Okay, of course the stress may be more here as compared to the ductile material, okay, but which exhibits very less deformation as compared to the ductile materials. So for suppose here the brittle material I am considering, this is the brittle material. Okay, when it is, so the material, I'm just drawing a material which is like this and which will go for external loads. Okay, for suppose if this material is brittle, then what will happen? It fails as like this. Okay, this is the same material. If it is ductile material, which exhibits some deformation just like this. Okay, so this is how the property of brittleness and ductileness in the materials. So these are the important mechanical properties that would be considered for any manufacturing operations.